go ahead to SWOT HR, and we're going to start the first tutorial for CryoCloud, which is the SWOT HR access. So that'll pop up. Again, if you can't keep up, like if you don't keep up, that's totally fine. You don't need to run through these. I'm going to run through this fairly quickly because this is data search and access. It's fairly simple, but you can come back and get more information if you want later. I do want to acknowledge that PODAC and NSIDC, which are NASA data centers, had tutorials that I've borrowed some information from. So you will see that within here, and I want to acknowledge them. What we'll learn in this tutorial is how to find and stream SWOT data directly into memory, and how to inspect those variables and visualize it. So this is basics for anybody who hasn't done this. I know a lot of people have already done this, so you can sit back if you've already used Earth Access a lot. We're going to use Earth Access for this. Note for beginners, again, streaming means not having to download directly into memory. What we'll do is we'll do a quick sign in to Earth Data Login. If you don't have the login for Earth Data, like your username and password, that's okay. You won't be able to run the tutorials here, but you can go click here and register for that right now if you want to. We're going to search for that raster data, open results in Earth Access, and then visualize it. And of course, this is meant for anybody who needs it. So SWOT background, the Surface Water and Ocean Topography mission run by NASA and CNES. All of the data is in the cloud. And the next tutorial we're going to do is to use this information we've built here, how to access SWOT, and compare SWOT HR data, high resolution data, to ISAT-2 over Bok ice shelf in the Antarctic Peninsula, and show you how to do some of that comparison. We're going to use, so HR is high resolution. There's an LR data, which is low resolution. It can have up to 10-meter spatial resolution. This product is 100-meter resolution that we're going to work with. And it's the water mask raster image. That's just the product that it comes in. So that's what this looks like here. And if you want more information about this product and SWOT, you can click on this link to check it out. We'll start by running this. I'm going to press Command Return or Shift Return. Shift Return is going to do this. It's going to move us to the next cell. If I do Command Return, this is on a Mac, so it's slightly different on a Windows machine. But if I use Command Return, I just stay there. I don't move to the next one. And you'll notice that Matplotlib widget, and I'll show you what that gives us later on. But we'll do that read-in. Here we're going to use the Earth Data Login and just run this. If you don't have a NetCDF, it's going, like I don't here, it's going to ask you to use your username, and I hope that's it. Let me get that really quickly. Small glitch. Not what I meant. Here and copy. So I found that. I'll run it again. Snow 3 and run. There's my password. This message doesn't pop up, so it's worked. And Earth Access uses the common metadata repository from NASA in the background. Earth Data Search does this as well, if you're familiar. So we can search data sets, and we can talk, there's advanced ways to search. You can check that out if you want to later. But we'll just do a search really quickly here for SWOT. So we say Earth Access search data sets, keyword SWOT. We're looking for anything that has SWOT. Cloud hosted, true. Everything for SWOT is in the cloud. And then version D, this is the most recent version. If you want a different version, you can type it in there or just delete this to get all of it. So if we run this, we end up getting 35 data sets, and we can get a summary for each by running this code here. So I'm just running this for the first 5 data sets. But what it'll show here is, Cloud Info region US West. So CryoCloud is run on Amazon Web Services US West 2 region. And so what this is telling us is this is the same region. In the cloud, there's three things. Joanna mentioned this before that we pay for: the hours that we use at compute and the size of the compute that we use. So if we use a large computer, it's way more money than if we use a small one. We pay for data storage. And three, we pay for egress. And egress means taking data out of one cloud region and putting it into another one. So that could be from Amazon to Google. It could be from Amazon US West 2 to Amazon US West 1. So to save money and not get charged for every file we're moving, it's ideal to be in the same place where we're crunching a ton of data from. So we're in the same place as Amazon. So that's good to note here. We're in the same place. You can get information about S3 credentials. So this is all like things that happen in the background. There's a lot of credentials here that are used to be able to access that data. Concept ID, this is individual to each of the data products and their versions. File format, get data, you can get information about each of these data sets. If you click on this, it'll take you to the description for it. And then the short name. This is the main thing that we normally know about: SWOT, L2, LR, SSH. This is like normally what we use for searching for things and working in Earth Access, and then version. So you can do this for all of these. And the main short names that we have here for SWOT are listed. These are all version D, but you can replace the D here at the end with 2.0 to get version C if you're interested. Some data is not yet produced in D, which is why I mentioned that. Today we'll be working with the HR raster data. Any tutorials that I know of that are associated with these data sets, I've listed here on the right-hand side. You can click on them, and this is going to take you to the PODAC tutorial for this. If you want to have other tutorials for working in the cloud, PODAC has a bunch of them for working with SWOT. There's all these different data sets, and then there's a hydrology and oceanography products tutorial there as well. You can click on those links. If you just want to see the short names for all of those collections, I'm just adding this little keyword thing here, and you can see all the ones that were listed in the top 5. So now we want to search for SWOT data using spatial and temporal filters. So we've created a bounding box for the area over Bach. And then we now have the short name that we want. We use the temporal range from May 1st to June 30th and add in that bounding box. And we get 4 granules from that. And once we get those granules, we can run this to really nicely look at what that data is and where it looks, where it lives. So this would normally pop up with a little tab, but SWOTs are broken. It seems like a little thumbnail picture showing you what it looks like. If you click on this, it'll take you to download the data. I don't recommend doing that. You'll have to log in first, but then it gives you a little information about each of those. That's just a nice way to look at it. And then you can open and load and display the data. Earth Access open with those results that we just had opens this into an object. And that's really important because working in the cloud kind of requires, thinking of things as objects rather than files. And that is, so AWS uses like cloud storage systems. So all the data that we're finding in the cloud is in these like object files. And then things like HDF5 libraries and the things that we're used to working with want like a file system, like a file. So this like open makes that transition for the cloud. So then you can open it into this. We're opening it into Xarray here, into a data set. And what's really nice is that as we visualize that Xarray, we can see the different dimensions, X and Y. These are the different coordinates that are there. These are the actual, like if we were to type in, ask for those coordinates, those are the numbers. And we can get information about each of those, the units, things like that. This is if you aren't familiar with working with Xarray. All the data variables are here and information about them. So longitude, Longitude is in degrees east, and it ranges from negative 130 to or 180 to positive 180. So we can find out all that information really nicely. And none of this data has actually been completely read in. It's lazy loaded. So until you actually are doing computations on it, we aren't sucking up very much memory. And then we want to work with a large time series. We want to read in a bunch at the same time. We want them to serialize based on their timestamp. And so we can use something like the file name, which is right here. This is what the file name is. There's a date here for when that file was taken. In Xarray, you can use this thing called preprocess, where you can add things like a time dimension. And that's what we do here. We grab this file name, grab the timestamp out of the file name, and run that preprocess function here. And so now Xarray is going to open MF dataset. That's going to open all 4 of these and add the time dimension. And once that's open, we will be able to look at specifically ds.time.values and see that all of these are the 4 different like time dimensions that we have. So this is still running. It takes a second to go. And then we will plot all of that using HVplot. So if anyone's familiar with HVplot, it's a really, really nice interactive way of visualizing Xarray, especially. So yeah, now you see we have that extra time dimension. And this is opening in just a second. Does anyone have any questions from this tutorial? Because we're finishing up this tutorial right now. I don't see anything. Cool. Everyone's keeping up. So this is HVplot. We can move this around. This is something that Matplotlib widgets helps with, is with our different plots, we can move things around. We can zoom in on this. So this is a height from one of the dates, and you can see this slider over here. It'll take us to the next image in just a second. It takes a second to load and open it. And so you can scroll through the different images from SWOT really easily. It's taking a little longer than it usually does. There it is. And so we can interact with each one if you want to like scroll through. So that's the access tutorial.